Hi, we're Team 70, and this is the Package Damage Monitor. It's a device that's packed full of sensors used to log all the events that happen to your package as it travels through the shipping system. Once the package arrives, you can take this box, push the button, and download all the data, upload it to the server, and then view all the events that might have happened to your package along the way.
Hi, my name is Gaurang Pakta, and I'm going to walk you through my PCB design and the components on the PCB. So here we have a 3D printed case designed in the SolidWorks. We can access the user interface button by just pressing straight up on the diving board. We also have a hole on the right on the top of the photoresistor to sense the light intensity. We also have a rectangular space on the top to plug the USB connector in. Whenever we tie these two together using the screws, both the top and the bottom compresses, so the PCB inside stays locked. Lastly, this material is also printed with the PCTG material, which is high impact and strength.
Hi, I'm Danny Carey, and I'm going to show you how to assemble the Package Damage Monitor. Okay. So we have 4 components. We have our liquid sensing strip, we have the case, and our PCB with our LiPo battery. The first thing we're going to do is plug in the LiPo battery into the connector for the board. It's kind of small, so now that that's in, now we're going to put this face down so they line up the light sensor with the hole. Once it's flush, we're going to take our liquid sensing strip and place it face down so it makes contact with the back of the PCB. And we're going to take our back of the case and place it on the top. Now that's all left to do is to screw in all these screws until they're tight.
Okay, so we have a lithium-ion polymer battery, which is 3.7 volts, 420 milliampere hour. Over here is a TPS63001, the DC to DC converter, the ADXL343, the accelerometer, BME280, the temperature, pressure, and the humidity, CP2104 USB to UART, SP32, the user interface button, LDR for the light sensor, and the capacitive touchpads for the liquid sensor.
So now that we've put the product together, I'm going to show you how a user interacts with it. Before we ship, we have a user interface button right here that does all the operations. So if we hold this button down for 6 seconds, we're going to clear out all this data. This same user interface button will let us upload the data later on. Then we release, it will flash rapidly to indicate that all the data has been cleared. Now to show you a little bit more about the internal code that I've written, I'm going to connect it to the USB port on the side so we can go into debug mode and look at the serial port output. So this is the serial output, which lets us look at what's happening on the inside. Every periodic time interval we set, right now it's at 30 seconds, the device will wake out of sleep mode, go into a higher power consumption mode, and read all of the sensors. So it'll do the light sensor, the weather, and the battery, then it'll go right back to sleep. Here we can see what caused it to wake up. So I'm going to introduce a touch sensor value, which is going to keep going and tell us all those readings. So it'll print out the touch sensor reading and tell us that it was woken by the touch sensor. If I give it an accelerometer tap there, the accelerometer values will print out, and at that time it'll also take a light sensor value in case the box was damaged at that time and was opened. So now that we're going to show you how the product works, we're going to ship our Hershey's bar along with the damage monitor and track any damage that may have happened to our bar along the way. One thing that's important to note when you're shipping the package damage monitor is that it has a lithium-ion battery inside of it. So we have to make sure that all of our packages have the warning label here so that it doesn't actually go in an air flight. In order to test temperature extremes, we're going to start off with an oven set to 550 degrees, and we're just going to hold it in front of it for a while. Next, to get cold temperatures, we're going to put it in the freezer. So next, we're going to put it in a hot shower room, the bathroom, shower on, get some humidity data.
In order to simulate what FedEx does to our packages, We're gonna drop it from the 6th floor for all build.
So to measure the barometer changes, which correlate to altitude, we're using this elevator to go from the 1st floor to the 12th floor, back and forth. So to simulate water damage, if it's left out in the rain, for instance, we're just gonna pour some water on it since we don't wanna drop the actual product in the water.
Hi, my name's Nayan Patel, and let's find out what happened to my candy bar. So we have the package damage monitor right here. If you hold the button down for 3 seconds, you enter Bluetooth transmit mode, the 3 lights. And then I have my iPhone app here with the IP address and port number. When you press enter, you see all the data is being transmitted in. Once the light goes off here, like it just did, you know that all the data is successfully transferred in. You press this button and it's successfully transferred. So now that we're in the app, if I wanted to view the data without seeing it on the server end, we can actually view it as graphs on the iOS app itself. So if you press the prepare button, it decodes the JSON and extracts the values in separate arrays, which we can then use to graph. So we will do that now. First, we'll look at the touch sensor values. Next, the light sensor values. Weather has 3 different options: pressure, barometer. So if you see that big dip there, that was when we put the damage monitor in the freezer. So that also correlates here with this temperature graph. When we put in the freezer is that big dip. And humidity, here is when we took the damage monitor inside of the shower. And so you can see that big rise there in the graph. And lastly, we will see the accelerometer graph.
Hi, my name is Abdullah, and my subsystem was the database, the data analysis, and the website. Once the app uploads the data to the HTTP server that I used Python to build, it analyzes the data and it looks for damage incidents. Then the damage incident is flagged. A table of the flags is saved. Both the data and the flags table is then uploaded to the Microsoft Azure database on the cloud. After it's saved in the cloud, then it's accessible at any time by the user using the website. Let's take a look at the website and see how can we look at the damage history. If we go to the Find Device tab, and then we go down and we enter the device ID and we search for it, we get a table of all the flags and the time occurred. So the type of damage. So there was a high humidity flag, a damage flag at this time, and there was the device was touched at this time, experienced low temperature. This is when we put it in the freezer, and this is moderate heat when we put it next to the oven. The package fell at a certain time, and it was open, and that's it. So these flags are all determined. Most of them are determined by setting the threshold manually. The full damage, we use the machine learning algorithm to determine the best threshold. All the flags could be improved, meaning we could improve the way we determine them, and we could add more flags and more diverse flags that indicate specific types of damage. Thank you.